The drive mechanism is located on the armature shaft and serves as the component through which the torque of the motor is transmitted to the engine. There have been several types of motor drives used over the years, but today most vehicles use an overrunning clutch drive. The overrunning clutch-type drive uses a one-way clutch. This clutch allows the armature shaft to lock with the drive gear in only one direction. When the cranking motor is turning the engine, the clutch locks up and transmits the starter motor's energy to the engine's ring gear. As soon as the engine starts and the speed of the ring gear and pinion gear exceed that of the motor, the pinion gear begins to freewheel as the one-way clutch loosens. The drive mechanism consists of a shell and sleeve assembly, the pinion and collar, the clutch spring, and the shift lever collar. The clutch assembly outer shell has 5 tapered notches machined into it. The pinion collar rotates inside of the clutch assembly. Between the two are 5 rollers, each pushed against the pinion collar with a spring. The clearances between these components are very slight. When the armature begins to rotate, the shell assembly turns. At that point, the rollers move slightly into the tapered area of the shell. Here they connect the pinion into the shell assembly. This allows the cranking motor's torque to be transmitted to the engine. When the engine starts and the pinion begins to turn faster than the armature can rotate, the rollers move back into the larger section of the clutch housing and uncouple the pinion from the armature. The rollers then act as bearings to allow the pinion to freewheel and avoid damage to the motor. The overrunning clutch also prevents damage to the cranking motor if the engine kicks back while cranking, by freewheeling on the reverse thrust. Let's examine how the pinion engages the engine's ring gear.